So, madam, shall we start? Let the participants join as they are.
Okay, sir.
Saraswati,
Yes, sir.
yeah.
So can I start?
Yes, yes, yes.
Good morning to one. India IAV, Puducherry Technological University. Uh, it's my pleasure to welcome you all to the second session on data analytics with Python. I would like to welcome our speaker, Ms. Elsa Sharo Johnson, to take over the session.
Thank you, Saraswati ma'am. So, I believe I'm audible.
Yes, ma'am. Yes, ma'am.
Yes, okay. So today's lecture, good morning everyone. Today's lecture will be in data operations with Numpy. So Numpy, it's a library in Python which is used to handle large multi-dimensional arrays, and it's used for data storage. And those who have known the basics of Python, you'll know about Python lists. So compared to Python lists, this NumPy arrays are very faster than Python lists. So first we'll look at the list. So this is how a list is represented. A list is represented by brackets. So before that, I'll tell you that I'll be doing my sessions in Google Collaboratory. So I hope you know how to take that. So you have to just type Google Collaboratory, and then you'll be made to go to a screen. You can select a new notebook, and from there you can change the name of your file. It's a notebook. It's in the form of a notebook, Python notebook, and these are the different options available. If you want to add a code, you can press here. If you want to add a text cell, you can press this one, and these are the run options. The file options have the options of opening, uploading notebooks, and all these things. You can explore all these options later. So then after that, after writing your codes, these are the options available. And for running, you can just click this play button, or you can put shift enter or control enter. Anything can be used. So I'll go back to my Python notebook. So list. So okay. So in Python, when you learn the basics, there are about four types of containers, namely list and tuple, then dictionaries, and after that sets. Okay, so all these are represented by different notations, like square brackets can be used to give lists, then tuples are given by round brackets, dictionaries and sets will be represented by curly brackets. Okay, so here I have shown a list. I'm just creating a Python list named as my list. I'll be running this cell. So before running, you just have to see whether your notebook is connected to the Python 3 Google Compute Engine backend. Okay, if you have some network issues, this might not be connected there. So you have to check for this one before running each and every program. Then if you want to see the type, I mean, what is the data type of the elements present in the list, you can just say print type of my list. If you give that, you will see that the class of this one is in the form of a list. Then if you want to see the elements of this list, you can do like just type the name itself, and you can see the elements present in this list. So these are the basic operations. Next, installing and importing libraries. So here, usually the Google Colab notebooks have this package installed. In any case you want to upgrade this package, you can use the pip command. Okay, so this can be used to upgrade your NumPy package. So sometimes it will upgrade, sometimes it will show dependency errors. So now it is installed. Then next one is importing the libraries. Before you do any NumPy operations in your arrays or have to do any mathematical operations, you have to first import the libraries. So I'll be importing NumPy as NP. This is the commonly used name for importing NumPy. Just NP. It can be used as an alias name for NumPy so that we don't have to repeatedly use the longer name. And this one also I'm importing right now because I have a small activity like that's like speed check. I just want to see whether my Python list or NumPy array is having more speed of execution. So I have just written a code here. I have just defined size of vector, and I am taking the present time of execution using the time module. That's why we have imported the time library. And we are storing it in time Python. Then I am creating two lists. So these are my list 1 and my list 2. So if you place this on the this particular portion, I mean, if you want to see what a particular command for function does, you can just place on it. So it will show that it return an object that produces a sequence of integers from start to stop. So now I given like size of vectors only. So it will produce a list with the given size 10 lakh and like that. So then I want to add these two lists. So when you're working with normal Python list, the problem is that for adding each and every element of the list, you'll have to go for a for loop. Okay, so I have given for I in range len of one of my list. Okay, so before that, I'll be showing this. The hash option is the command option. So for I in range len of my list. Okay, for this particular range because that's the same for both. So in this range, I want to add each and every element of my list 1 and my list 2, and then so a for loop should be used here, and the end time is taken by this module and the difference is taken and returned. And the next function is define numpy version. So here also I'll be taking the time and I'll be defining two arrays like my array 1 and my array 2. And for this option, the arrange option, I mean, this is the numpy function for giving a size of vector. Okay, so this, what it does is that if we give the size of vector as this one, it will form an array in the given size. So the advantage with NumPy array is that where we have used a for loop in the case of Python list, we don't have to use a loop here. We can just add the two arrays directly. And the time is also given here. And then we are printing the time taken by both the programs. So
One message came that your voice is not clear, so you can be louder, no, little bit.
okay, so
You ask once.
is my voice not clear?
Audible.
Ma'am,
Yeah.
it's quite low. Like I'm not able to understand only because it's so low.
Okay.
Okay.
Quite low. You can be little bit louder actually. That will be fine, no?
Okay.
Little bit louder.
Okay, now it's audible. Is it audible?
Yes, ma'am. Thank you.
Okay. So I have just shown the time taken by each of the Python list as well as the NumPy array. So I have given a for loop to show the addition of two lists and given in the sum list, and also the difference with NumPy array is that you can just add these two arrays directly. Okay, so for that I am taking the time in both the cases, and when I see the time, I'll just run this block. Okay, so you'll get the pure Python version time as 0.3, and the NumPy version has 0.0052 seconds. Okay, so in this example, your NumPy example is NumPy function has 61.555 times faster execution than pure Python version. Okay, from this you can see that NumPy is way more faster than Python list. Now my voice is clear, right?
Yes, sir.
Okay,
Yes,
so
ma'am.
now we'll go to the creation of NumPy arrays. So NumPy array will be an n-dimensional array, or it's called as an ND array. Okay, then we'll just see how it is created. So we have to give np dot array of my list. Okay, so my list is a list that was created. So to change it to an array, we have to give this command np dot array, and it will be stored to arr. Okay, and if we give the type of arr, if it's printed, then you will get like the class will be numpy of dot nd array. Okay, so nd array means n dimensional array, and it will be displayed like this. Okay, so this one is an array of one dimension. Okay, so I just have a cell like this. My scalar, I have given this value is as 12. So can you tell me what the dimension of this my scalar is? Anyone can send a message in chat window. It's displayed to me. My scalar. Okay, can you tell me what the dimension is of that my scalar, my underscore scalar? Okay. So for my list one, what is the dimension? One person has told like first one has one dimension. So can you tell me what the dimension of the next one is? Okay, so can you see any difference between these two? My scalar, okay, this one and this one, it has a difference, right? So what can be the dimensions? Okay, what you said about this one is true. Okay, my list one is of one dimension, but the top one, it is a scalar. Yeah, one person has replied. So it is a scalar, it doesn't have any dimension. Okay, so if you simply give a number like this, it's a scalar value. Okay, this is having one dimension and this is of two dimension. Okay, how can you say this having two dimension? Anyway, you just have to see how many opening or closing brackets are there in sequence. Okay, so here at the third one in my list 3, I have 3 brackets here. Okay, so and opening sequence in brackets in sequence are also 3. So if the number of brackets in sequence are 3, then your dimension is 3. Okay, I'll just run this block, and then this is the command used to find out the dimension of your array. So if I just run that thing, you can see that it is 3. If I run it for my list 1, then I can see that the dimension is 1. Okay, so this is how we find the dimensions. Now, if you want to create it as a matrix, okay, as a, I mean, not a 2D array, then you two-dimensional array, then you have to give it like this. We have seen, no, the number of opening sequence or closing sequence of brackets is 2 here. So I'll give like my mat equal to this one, and then I'll be creating an array named like mat, And if you give the type, then it will output like this one. And if I give the dimension of this one as
Is it possible to increase the font size so that
oh,
in the view, I think that's option. You please see if it is there. You please increase the font size.
is it bigger now?
Yes, yes.
Okay,
Maximum possible size. If you go, then those who are using mobile, it's very difficult to see.
okay, sir.
Monitor okay, but for mother, those who are using mobile, very difficult to see. That's why
Okay,
maximum possible size you give.
is it visible now?
Yes, yes, yes.
Okay, so this is about the NumPy array and its dimensions. Then we'll check the array attributes. Okay, these are the different array attributes like shape, endim, and data type. So how to see this one? Okay, so what I'll do is I'll display the type of ARR and the ARR output values. Okay, so type is one of the data type, or type is one of the attributes. And then if I want to, I'll just create the matrix once more. So it's visible, I think. So how to, I mean, if you want to comment a specific line, you can put um, hash in at the front of that line. Okay, so my math, I'm defining it like this, and I'm converting it to an array just like I have done earlier. So it forms an array like this. Okay, it's a 2D array. Then if I want to see what is the array shape and what is the matrix shape, so array I have given as a 1D array, and the other one I have given as a 2D array. So the 1D array has a shape of how much ARR. ARR was given earlier. So ARR has a shape of 5. Okay. And then ARR has a shape of 5, and then mat has a shape of 4 rows and 3 columns. Okay. Then if you want to find out the dimension of both, then you can see as the array resolution is 1 and the metric, I mean, it's the array 1, the ARR is a 1D array, and matrix is mat is a 2D array. Okay, then this is another attribute, d type. Okay, so if you want the type, to know the type of information stored in an array, you have to type arr dot d type or math.dtype for the matrix. Okay, so I have given like arr theta. Arr is a function is an array containing just 1, 2, 3, 5. Okay, and this is just a matrix containing numbers. So both has come as int 64. Okay, so for the time being, if I change the one of the elements as a string, and so now one of it has come as a string, and then if I am checking at the data type for this one, then it has come as like Unicode 21. Okay, both all of them has taken as a string. Okay, so I'll just change it backward, I mean it's to its original form. So it will tell you what is the data types that is stored. Okay, so now we have seen to make use of shape, indent, and data type. Shape will show the how it is arranged, how many rows and columns are present in case of a 2D array. Then next one is array initialization. So this is to initialize our array, and these are the different methods used like a range, zeros, ones, linspace, and we'll see each one of them one by one. So the first one is like generating an array of size 10. Okay, so I'm starting with 0. Okay, so the Python indexing also starts with 0 for so to make it easy to get the indexes as same as elements, I'm starting with 0. So 0, and I'm giving the ending value as 10. So here it means that when you get the array, 10 will be excluded. I mean, till 10, the values will be coming, and this is the step size. Okay. So if you give it like this, the Python will automatically get the data type. You don't have to specify it. So I'm arranging it as np.arange, and I'm getting the values from 0, and the ending value is still 9. Okay, 10 will not be included. Then this index is also like 0 has the 0th index, 1 has first index, and 9 has 9th index. Okay. Now, if you want to change this and generate an array of size 10 with step 2, step 2 means 0, after that 1 step and 2 steps. Okay. So if I want to get this like after 1 step and then second step. So if you give it like this, that means 0, 10, and 2, then you will be getting the numbers as 0, 2, 4, 6, and 8. Okay, 10 is not included, so it won't be coming. So if you give like that, your answer will be till 8. Okay, now if you give np.zeros, zeros is a command that is used to generate zeros for the number which is given in the bracket. Okay, so if you give like shape is equal to 4, then you can say like 0 point, like it will, the answer will always be coming like a float. Okay, so Python has that functionality to give you like a provision for making it as a float if required. Now, if you want to see, and there is another thing, like if you are in doubt of one or two functions to be used, you can just type np, and in np, if you type z, you will see that with z what all things are coming. Then if np dot, if you want to see what is there in the starting with this number, you can see a range is there. Then if ar is there, then array is there. All these things will be displayed by your Python itself. Okay, you just have to type and see what all should be coming. So if you require ones, for example, if you need to create ones, you just have to type O, and you can see the different functions that are starting with O. Okay, so this is an easy functionality of Google Colab. Jupyter Notebook also it has, you just have to press Shift Tab. Okay, then if you want to give two-dimensional zeros, okay, I've just shown a one-dimensional array of zeros. If you want to give a two-dimensional, or then I mean if size 3 cross 3, then you just have to give the shape as 3 comma 3. Okay, and its resolution is also shown. Resolution is a 2D array, and this 2D array has 3 rows and 3 columns. Okay, then the next one is of ones. Okay, ones is used to generate an array of size 3 by 3. Okay, so I'll type the command ones and then shape 3 comma 3. Then you will get an array having ones only. Okay, so then this one. Next one is linspace. Linspace is used to get equally spaced. Okay, if you type in that, you will see that return evenly spaced number over a specified interval. Okay, I hope you can see the command explanations also in your window. If you're not seeing, just put a message. Okay, so linspace, you have to specify what should be the start and then where to stop and how many elements you need to give. Okay, so I've given like start as 0, stop as 5, and numbers as 10. So now if you run this, you can get like, 10 elements are there and it's divided like this. So if I give number equal to 6, then you will get an evenly spaced, which looks okay also, because from 0 till 5 there are 6 numbers. So if I give the number of elements as 6, you can see the integers itself. Then if I give it like another value like 20, then it will be 20 elements will be coming which are evenly spaced. Okay, so this is the functionality of linspace. The next one, np.I. What it does is that it generates a 2D array which has its diagonal elements as 1. Okay, so if I run this, you can see this one coming. Okay, next is random array initialization. So these in here, there are two different commands. Okay, so one is rand and the other one is rand n. Okay, so what first one does is that it generates an array of the given shape and populate it with random samples from a uniform distribution over 0 and 1. What rand n does is that it forms the same thing, but the distribution will be of standard normal distribution with mean 0 and variance 1. Okay, so first if I give like np.random.rand as 5, then an array will be created. Okay, it has a uniform distribution. And next, as an example, if I give like rand 2 comma 2, then a 2D array will be created with 2 rows and 2 columns, and this will be following a uniform distribution. Okay, next is rand n. What's the difference here? It's following, this will be following a normal distribution. So what is normal distribution? The mean will be 0 and the variance will be 1. Okay, so all these numbers, it will have a mean close to 0 and the variance will be of these elements will be 1. So what usually, how is the figure of a normal distribution? A normal distribution will have a bell-shaped curve. Okay, and this shape, this will be the shape of the distribution, and you might have studied this between, if this is your -1 and 1, about 67 percentage of your data will be residing in this individual, 67.7 percentage. And next one, about 95.8 percentage of your data will be residing in between -2 and 2. I hope you have studied this. So we'll look at that later. Then if you want an array, this is just, I have just given it like again. So if I run it, we have a resolution like this, and if I have reshaped it, this is another command. What it does is that I have first defined a random array that was one dimension. Now I'm changing it to a 3 by 2 array. Okay, so here if I give the reshape command and give like 3 comma 2, then it will have 3 rows and 2 columns. Okay, so this particular command, it's widely used in many of your data science problems. In many places it might be required. Okay, now we'll see a close look at the normal distribution. Okay, so I am defining a variable like lect array, and I'm giving about 1000 values. Okay, so 1000 values in rand. Okay, and if I run this block, I'll form an array with 1000 values. Okay, and now I want to see how many values are there between two given values. Okay, so just I'll draw that distribution once again, and so this is your normal distribution. I hope you can see the curve. Yes. Okay, so yes. So this is between 1 and 1. I have other value between -2 and 2. Okay, so I just want to find out how many values are there between these two elements. Okay, I mean between these two numbers. Okay, so what I have to do is that I just have to tell let array, that is our name of given to our array, and I just have to see what's between these two. Okay, so if I run this code, I'll get 683. Okay, so that means that I'm getting out of 1000 element about 683 are in between these two values. Okay, that means this particular interval contains about 68.3 percentage of the values. Okay, so you have studied it in normal distribution too, between -1 and 1. That means your variance sigma is 1. So between minus sigma and sigma, about 68.3 percentage of your value will come. Okay, now we'll see what will happen if we give -2 and 2. Okay, and if we see the shape, what we'll obtain. So if we give that, we'll get 94.99. 949 by 1000 into 100 will give 94.9. So the next one, the next interval will contain 94.9. Okay, this will vary up to I mean, it can come up to 95 also. Some variances will come in between 90. Here now we got like 94.9 percentage of the data will be residing in this interval. Now if we change it to -3 to 3, then about 99.5 percentage of the data is in that interval. Okay, so this is about normal distribution. Okay, so now we'll find the mean of that array. So I'll run this one, and then I'll find the mean of that array. So it's coming close to 1. It's coming as 0.01. So now what I'll see, like if we go to a survey and all, we'll collect a large number of data. And when we do the calculations on those data, we won't be taking it with the whole data itself in any survey. We'll first collect a small interval. So that is known as a population and a sample. Okay, so this one can be taken as a population, and I am choosing a sample from that. So choosing a sample, this is the code for that. So if I select like then equal to np.random.choice, and from where should I take this one? From my array. Okay, lecture array, and I want about 10 samples. Okay, so if I give like that, I'll just display it here, then I'll get about 10 samples from that array. Okay, so now I'm going to check how much is the mean of that sample. Okay, so what I'll have to do is I'll just put this dot mean. Okay, then if I run that program, then I'll see that of the 10 samples I have taken from lecture array, I'm getting a mean of point this one. Okay, point minus 0.08. Okay, now this program is like I'm giving a for loop, and for instead of doing this every time, I'll be giving like in for loop from this much when the sample is taken as this much, and I'll take about 10 times 10 iterations are done of that samples. Okay, the number of samples I have chosen is 100, and about 10 iterations of that particular operation is done. I'm adding it every time to some average, and I want to see how much is the mean coming in each of these samples. So if I run that, I'll see that it's close to 0.05, but our lecture array mean was 0.01. Okay, so I'm just increasing it to 50. So if 50 comes, then it's 0.003. So I'm just reducing it to 30. Then if 30 is taken, 0.02. So if somewhere in between this value, that our mean becomes equal to the lecture array mean. So we have to go with that particular number of times, okay, to get the sample mean as close as the population mean. Okay, so this is one of the operations done. Next, we'll move on to Numpy indexing. So I'll just form an array with the following, with the given start and stop values. So 0 till 10 with step 1. Okay, the first element I am just full array will be displayed like this. Okay, and if you want to see the first element, that means index 1, then you have to give like my array of 1. Okay, so these two are displayed. Now array slicing. So if you want to access more than one element of an array using slicing operation, you can use array slicing. So I'm just creating once more, and I'm printing the full array. Okay, so this is the full array that I've created. Now I want to access elements ranging from 1 to 5. So if I give like my array 1 colon 5, then if I run it, then I'll get like 1 2 3 4. Okay, and this fifth one, this won't be included. Okay, the first element is extract, that is of index 1, and the last element is of index 5 minus 1. So if you are accessing like this one, this is the method in which it will be extracted. Okay, now if I give like starting index as 8, and I'm just leaving it like that with no ending, then whatever is there in index 8 and the remaining will all be printed. Okay, now if I'm giving like starting nothing I'm giving and ending index I'm giving, then starting from 0 index 0 1 2 3 4 5, all those will be printed. Now if I want to place -5 value to all these indexes, okay, ranging from 0 to 5, then I can do the specific operation, and you can see my array changed like this. I mean starting from 0 index 0, 1, 2, 3 and 4 till this index, my value will be changed to -5. Okay, then 2D arrays also slicing can be done, and so I'm giving a 2D array named as ARR 2D. So this is the 2D array present, and if I want to access the element present at the 0th row and the second column, okay, 0th row is which one? 0, 1, 2, and the second column is 2. Okay, this one 2, 5, 8, 11. So if that has to be done, then I'll have to give it like this 0, 2. So what will be the answer? 2. 2 will be obtained. Okay. Next, this is accessing some other elements. Okay. So what I can tell is that if I want to access these 0, then 2, then 6 and 8. Okay, so how should I give it? Okay, what should I do in case of that? Okay, so I will first see. Okay, sorry. We'll first see this one. I mean, if we do like this 0 to 2, 0 to 2, then we'll get the first and second and the first and second column, first and second row and first and second column. Okay, so that will mean like 0 to 2 means okay. This this much and this much will be coming. Okay, these will be accessed there. So if we run this specific code, okay, this will be coming. 0, 1, 3, 4. Now I want to access these elements. I'll just show these. Okay, you can tell me how to do that. Sorry. Okay, so if I want to access 3, 5, uh, 3, 5, 9, 11, then what should be done? Okay, so here also the same function can be taken. Okay, I'll just show that. Then I want to access these things 3, 5, 9, and 11. Okay, so how can this be done? Can anyone suggest in the chat window if someone knows it? I mean, I'll just put like this. Okay, I'll just show you. I mean, this 3, which, what is the row number of this 3? Okay, array 1, 2, 3 and array 1, 2, 3. Ruhin has given one answer. We'll just see. Okay, 1, 2, 3. Okay, and 1, 2, 3. Okay, yeah. If you run like that, you will get what? 4, 5. Okay, I'm trying to bring that to position. Okay, just I'll do it once more. 3, 5, 9, and 11. So what does the answer came? Actually, Ruhin, can you modify your answer? Okay, you saw the answer, no? It came as 4, 5, 7, 8. Okay, what was the thing actually? When you put 1, which row is accessed actually? Row is okay, 3, 4, 5 row and 9, 10, 11. Okay, I'll tell. And next one, you put the column also as 1, 2, 3. Column 1 is this one, 1, 4, 7, 10. Okay, so you have accessed this column instead of 0, 3, 6, 9. That's why the answer came like 4, 5, 7, 8. Okay, so and till 3 you have given, there is I mean 1 column 3. Okay, so so here what has happened is that like that values can be, I mean not much values are present like that. So what here you have to do is you, if you want to access this 3 and this first column, then you have to put it like this 1, 3, let it be like that. Then you can put 0 and till 3. Okay, 0, 1, 2 till 3 you can put. And another thing is like 3, 0, 1, 2, 3. If 3 comes like that, this is the third row. Okay, if you give 3 like that, it won't be included, it will be excluded. So if you want to include that, you have to give 4. Okay. So if you run like this, you will get everything like that. Okay, so what you have to do, you have to exclude the middle rows and columns. So here what you can do is like you can give 1 to 4 with a step size of 2, and here also 1 to 2 with a step size of 2. Okay, now what have you got? You have got 3, 5, 9, 11. Okay, so instead of giving this like this, I think you have understood this one. Can you put a yes or no if you have understood or not understood? Has everyone understood? I hope there is no doubt about it. So instead of doing like this, I mean, you don't have to find out what is the ending column or row. You just don't have to specify the ending value. And if you run like this, then you will get the same answer, 3, 5, 9, 11. Okay. Now, next is like, so this is array indexing, then conditional array indexing. So I'll just run this thing, and I want to see what all values are greater than 2. Okay, so if I just give like this and give greater than 2, I'll get an error. Okay, so can you tell me what this is? ARR is a list of elements. Okay, and for list you can't give this value. Okay, greater than simple is not supported between instances of list and int. Okay, your values are int, I mean your value is int and you have given a list, so directly you can't do this. Okay, so what you can do is that we have learned about numpy arrays, right? So I'll just come in this line and just make it an array. np.array object equal to AR. We just don't have to give it, we can directly give like array itself. And if now you give, you'll see which all elements are greater than 2. So your elements are 1, 2, 3, 4, 5. These two are not greater, so false will be coming. Okay, and I have given another one to find out the length of that array. So I have given ARR equal to np.arrange 2 to 15. So 14 till 14 elements will be coming, and its length is 13. Okay. Now this you can find later if I'm defining something as this one and then running. So it's not defined, sorry. It's, if you give like this, then you will find where it's getting true as a condition. Okay, I mean true is given to the second element, so true comes in 2, 4 and 6, so that specific elements will be given. Then this is similar only, sorry. Then I want to see true for elements that are greater than 8, so I'll get true there, and output actual based on the condition passed. I mean, I want to see the elements which have a number greater than 8, then I have to give like AR. This condition should be given inside a square bracket and of that array. Okay, if you give like that, you'll get what all are the elements, and if you give in this form, you'll get like where the condition becomes true. Now if you want to see the elements present at index 1 to 4, then you can see it like this. And so this is the conditional elements, I mean greater than. These are the different things that you can use here in NumPy. Now NumPy array operations, first one is broadcasting. Okay, so we'll see what broadcasting is. I have given two arrays with the name A and B. Now here when I do this, I want to give this operation A into B. So if I run this particular thing, I'll get the value as 1 into 2. Then second element of both arrays, 2 into 2 as 4 and 3 into 2 as 6. That will be happening immediately. So this thing is normally, but when you give array A as an array having 3 elements and B with a scalar value, what will be the result? So here what it does is that to get rid of problems coming with the dimension of this one, it will broadcast this to an array having the same number of elements as A. So if you run this program, you will get like the same result as earlier, just that the B will be broadcasted as an array having elements 2, 2, and 2. Okay, so your answer will be coming the same here. Okay, so I'll just show this with a figure. So now, you have two arrays like this. Okay, having a 4 by 3 matrix, and this one also 4 by 3 2D array, and this one also like that. So if you add these two, it's pretty normal only. Every elements will be added and the result will be like similar. Okay, now if you are trying to do this initial one and you want to add this one, what Python does is that this same 1D array will be broadcasted to all the rows present, and then after this only the addition will be performed and the result will be coming like this. Okay, and suppose if you have a 1D array like this, okay, in this manner, and you have another 1D array like this. Okay, so now addition directly is not possible. So Python broadcasts this value like 0, 10, 10, 20, 10. This will be broadcasted to two other columns, and for the next array 0, 1, 2 will be broadcasted to two other rows, and you'll get the output like this one itself. Okay, so I think that's understood. Okay, then I'll just show you another example. Okay, so I have an in array 1 as this one, and array 2D was given earlier. So okay, array 2D, I'll just run this program. So a scalar is given, NumPy has broadcasted it, and the value is coming. Okay, now then I'm giving another array in this value, ARR 1D. Okay, shape is like 3. Okay, the shape of the other one is like 4 cross 3, and the shape of this one is like 3 cross 1. Okay, no, 1 cross 3. Okay, so if you are trying to add both these, what will happen? Okay, it is okay because this is the first one is 4 cross 3 and next one is 1 cross 3. So it has broadcasted like 10, 10, 10. It has come broadcasted to 3 more rows. Okay, now if I'm giving another one like ARR as a NumPy array of 1, okay, this is one is that. You have seen what ARR2D is. ARR2D is of the shape, this one. Sorry, this one is the shape of ARR2D. Okay, and the new one I'm trying to add both these. So what will happen? This tells that first one has a shape of 4 3 and the next one has 1 4. Okay, so these two, it should have some similarity. Okay, if it was 1 3, it could have been broadcasted, or it was the shape of ARR was 4 1, it could have been broadcasted. So I can do one other operation here. I can transpose this matrix and just run it once. So it's not, sorry, it's not a built-in function. Okay. Oh. What was ARR? Okay, then this is both is not happening in this one. Okay, I'll see that. Okay, first if you do like this, these operands couldn't be broadcasted together with shape 4 3 and 1 4. So what can you do in that method? Okay, you want it to make in a shape like 1 cross 3. Okay, so here it's like okay, and if you add it then it will be okay, because now the shape has come like 1 3, and the other one had a shape like 4 comma 3. So this one is okay. If you give it as another shape, means like I have given earlier, that wouldn't have been possible. Okay. Now, NumPy mathematical functions. So these are the different mathematical functions like min, max, argmin, argmax, square root, mean, and exponential. Okay. So I just given a value again, like this array, and I want to see what are the minimum, maximum. ARG minimum means the index, it gives the index where the minimum value is present, and ARG max will give the index where the maximum value is present. Okay, so these mathematical operators, I can just run it directly. These are all defined inside. Okay, so if you run it, you can see like this one. Okay, this is the maximum value, minimum value, the position. Okay, now I want to see what is the square root. Okay, so just see what happens if I run this program. Okay, so now we have got like ARR. I have given it in the same fashion, ARR.argmax is the mathematical function, so I have given it like that. Okay, but an error was thrown like numpy.emptyArray object has no attribute sqrt. Okay, so this has come because some of the functions won't be present in that particular object. Okay, it will be present only in NumPy. Okay, so what you have to do in this particular case is that you have to give np dot square root of error. Okay, so what I have to do is like I have to cut this one, give it here, and I have to give np dot. Okay, so if I run like that, then I'll get the square root of elements in array. So this is the same for exponential also, because that particular function is not contained in the nd array, it is present in NumPy. Okay, now I'm just defined this array ARR1, and I'll give like I want to find out where the ARR1 has a minimum value. Okay, so if I'm running it, I'll find that okay, ARR1 has a minimum value of 1 1 in indexes 0 and 2. Okay, now I want to find out where this one, I mean, if I give this specific function, what will happen? Let's see that. So if I run like this, then only the index which has, I mean, the second index will be coming. And -1 is like a type of negative indexing. Okay, so we had the result as 0 2 earlier, So 0 2, if we give -1, then the indexing will be coming, the indexing will be coming like 0 2, and if you give -1 there, then negative indexing starts with -1. As I have told you, like positive indexing starts with 0, negative indexing starts with -1. So if I give -1 here, then 2 will be coming. If I give -2, then 0 will be coming. Okay, we'll just try that, and I'll just give -2. Okay, so I should get 0. So 0 I'm getting. So this is the next index. Okay, if I give -1, the first index in the reverse order where we are getting minimum value. Okay. Then array manipulation. These are the different reshape, transpose. Transpose I have shown earlier. Flatten, reshape. Reshape also I have shown earlier. Okay. So I'm just defining ARR in this method from 0 to 16. 16 not included. And if I'm giving reshape for 4 means I have to convert this 1D array to 2D array with shape 4 rows and 4 columns. So if I run this one, I'll get a matrix, 4 by 4 matrix. Okay, Now, I again want to convert this to a 1D array. So what is the command to be used? Flatten. Okay. I have to type this flatten. Okay. Now, if I want to transpose, okay, so transpose, if you want to, this is the array which is present earlier. I want to see the transpose of this one. So if you run that, okay, it will come as transpose. 0, 1, 2, 3 was in the first row, it will come in the first column. Okay. Now, array merging and splitting. I think till now it's everyone is fine with this. Someone is there entering, want to enter? Okay. Yes, so these are the different merging and splitting operations: concatenate, edge split, horizontal split, and vertical split. Okay, so I am defining an array like this: x array x and array y, and I want to concatenate these two with axis 1. Axis 1 means it will be concatenated column wise. Okay, so now you can see this was the first array and this was the second array. Column wise concatenating means this one will be present, and in the next columns the other array will be coming. So if you want to change this to a row, okay, if you want to change this to a row, then you just have to give axis equal to 0. Okay, now if you do like this, you can see that the first array is coming like this and the second one will be added row wise. Okay, now this next one is horizontal split. Okay, so the original array was this one. Okay, this is the original array, and we want to see a horizontal split of the array. Okay, so what the result will be is, sorry, okay, I have to run this one. So I have concatenated both these arrays row wise. Okay, and if I'm running this, I want to split it horizontally. Horizontally means, so what will happen is that this one will be the first array, and 3, 4, 7, 8, 23, 24, 27, 28 will be the second array will become. Okay, so similarly, if I'm giving vertical split, then from the initial one, 1, 2, 3, 4, vertically this much, like, I mean, the split will be happening like here. This much it will be split like this, and the value will be coming like 1, 2, 3, 4, 5, 6, 7, 8 is one array, and the next split will be like the rest. Okay. Now, so these are about the data operations with Numpy. I believe you have understood everything. So it's an open source add-in module to Python, and by using, you can speed up your workflow operations. So Numpy, it's used in some of the operations in data science, and another powerful library is present known as pandas, which we'll be looking at the next lecture. So there we'll see, and in that programs also some operations are present where you have to use NumPy. Okay, so these are the different things you have finished the basic things you have to learn about NumPy. Thank you. I hope everyone has understood it. If you have some other doubts, you can just ask now.
Wherever.
Yes, sir. It's my privilege to propose a vote of thanks on this occasion. On behalf of Puducherry Technological University, I extend a hearty thanks to our chief guest, Ms. Elsa Sharu Johnson, who spared her precious time to grace this occasion. Thank you, ma'am.
Thank you for including me.
We have the videos after the 4 days. We have consecutive 4 Saturdays. After the fourth day, we'll be sharing all the videos, and as well as we'll provide certificate for the students who have completed all the 4 days.
Okay, sir.
Okay.
I'll be sharing the
All of you kindly fill the feedback form that is given in the chat window.
So I think this is the end of this lecture. Thank
Yes,
you.
yes. Thank you.